Everyone, my name is Anthony Nathaniel and I welcome you back to Global Education Zone. And in this video, we are going to be talking specifically about the sine rule. Now, the sine rule, we are going to be taking trigonometry a step further from our SOHCAHTOA and trigonometric ratios onto the sine rule. Now, the sine rule is basically a rule that exemplifies and denotes the relationship between the sides and the sine of the angles. The side and the sine of the opposite angles. That's what it means. Now, there's a proof for this, and I'll show you the proof now. For example, if we have a triangle A perpendicular, we have triangle A, C. I also have another triangle. This from here to here. So this is just a sketch, though. So if this is ABC and this is A, this is also ABC. Now in this case, this will be C, ABC, BC is A, this is H, and this is B. Yeah. Then we also have similarly, we have this is B and this is C, this is A, this is B, and this is H. Now from what we can see here, these are two triangles, right? Now what will sine B here? The sine of this angle B will be what? Opposite to hypotenuse. That will be what? Sine B is equals to H over C. That's for this first triangle. And at the same time, we can also say for this first triangle too, we can say sine C is what? H over B. Sine C equals to H over B. That's for this sine C is H over B, opposite by hypotenuse. Now for this second triangle, we can say sine B is B over C. Sine B is equals to, for this first triangle, we can say sine 180 minus C. If this is C, yeah. Rather, if this is C, this is C here. So if this is C here, we can say that sine 180 minus C is H over B. So sine 180 minus C is equals to H over B. And the reason for that is that if this is C, then this angle will be equals to 180 minus C. So this angle is C, and this one will be 180 minus C. So the sine of this angle here will be opposite to hypotenuse. That's H over B. So that's why it's the case. But from our trigonometric ratios and the four quadrants, you can know that I talked about this in the previous episode. You can also check that out. But the thing is, sine 180 minus C is equals to sine C. So that means sine C will be equals to sine 180 minus C, and that's equals to H over B. So it's true. It has been proven in the previous video. Now, if sine C is H over B and sine C is sine C is H over B and sine C is H over C. So that means if we combine these equations together, we have sine B is equals to H over C, and also sine C is equals to H over B. So we can say that H will be equals to what? If we cross multiply, that means H equals C sine B, and also at the same time H equals what? B sine C. Because since the H is constant, they both have the same height. So if C sine B is equals to B sine C, let's divide both sides by BC. Let's divide both sides by sine B sine C. Divide by sine B sine C. Divide by sine B sine C. So that means sine B cancels out. That will be C over sine C. C over sine C equals B over sine B. Now this is the basic statement of the sine rule, and you can also say that you can also prove that conversely, at the same time, A over sine A will also be valid. So A over sine A equals B over sine B equals C over sine C. So this is the simple statement of the sine rule. And then let's see what we can do about this. Let's say let me give a question. Find the remaining angles of triangle ABC in which A is 12.5, C is 17.7, and C is 116 degrees. That's the angles and the sides. Let's work with that. So here we're asked to do what? Now in this triangle ABC, we are given triangle ABC right here. Then this is B, and this is A, and this is C. Then this AB is 17.7 centimeter, and then this angle is 116 degrees, and then this is 12.5 centimeter. Now we are asked to look for find the remaining angles. We are asked to find the remaining angles, but specifically, let's look for the value of angle A. Let's look for the value of angle A now. So now we will make it basically use sine rule, which says that side A over sine A equals side B over sine B equals side C over sine C. So this side A is what? This is side A. The side A is the side facing the angle A. That's 12.5 over this sine A is what? Let's call it sine A. We don't know what it is. We don't know what A is. So that's the angle we're looking for now. Equals sine B. Side B is what? We don't know what. So let's write it. B over sine B is what? This angle we don't know it. Let's write it sine B. Equals side C. Side C is 17.7 over. Then the sine B is sine 116 degrees. So we can simply discard this middle equation and use the first and last. That means 12.5 over sine A equals 17.7 over sine 116 degrees. So now we can simply make this sine A the subject by saying sine A equals 12.5 times sine 116 degrees divided by 17.7. So if we look for the sine inverse of this, that means A will be equal to A is the sine inverse of this, and this is what? Everything here is that would give us, that's 12.5 times sine 116 divided by 17.7. So the sine inverse of this will give us 39.4 degrees. That would be the value of angle A, 39.4 degrees. Now I can also give you this as a work to do. You can look for the value of sine B of the value of B by using the fact that the sum of angles in a triangle is 180. So since you've gotten angle A and you've gotten angle B, you've gotten angle A and you've gotten angle C, you can also solve for angle B by equating everything to 180 degrees. So that is simply how sine rule works. So that's then let's quickly brush up some things about bearing and distance. So bearing and distance, the bearing of a point from another point is the angle which we have to turn from that first point in order to get to the second point. So for example, the bearing of B from A now is the angle we have to turn from A in order to get to B. So bearing simply, if you have 2 points, A and B, this is A and B. Now the bearing of A from B is the angle from B which you have to turn in order to get to A. For example, if this is the line joining them together, and these are the 4 cardinal points. So in bearing you make use of cardinal points. So these are the 4 cardinal points. Now the bearing of this A from B is the angle you have to turn like this, and this angle is a clockwise angle. So you turn a clockwise angle from here to get to B. But the bearing of B from A is the angle you have to turn from A in order to get to B, which is this clockwise angle. Yeah. So you make use of clockwise angles in bearing, because in a particular video I talk about the fact that you can use clockwise or anti-clockwise depending on the condition. So when you are dealing with bearing, you make use of clockwise angles. So this is it. But when you are making use of when you are talking about the 4 quadrants, the measuring of angles, you make use of anti-clockwise angles. So there are different conventions. But then bearings, using these bearings, you can use it to solve questions, and in subsequent videos I'll also talk about questions using bearings. Thank you for watching, and see you in the next episode.